Yes. Hello, dear students. In last class, we have discussed about the stress strain curve. So, based on that, we are going to decide now brittle materials, ductile materials, and elastomers. We are going to discuss here. So, we are going to discuss first brittle materials. Brittle materials. Next, we need to know ductile materials. And we need to know about the elastomers. So, what is meant by brittle materials means for brittle materials, you will get a graph like this. How will get the graph? This is stress. This is strain. Stress versus strain, if you take graph now, you'll get graph like this. And ductile materials we are taking like this. You'll get graph representation like this. This is stress. This is strain. If you draw the graph now, graph will get like this. Like this. Next, elastomers, if you want to draw a graph, stress versus strain curve. Stress versus strain curve if you want to write it now. So you'll get a graph like this. You'll get a graph like this. So if you observe here now, in this is nothing but which region? From here to your elastic region, from here to your what we can call it as plastic region, right? Plastic region. In brittle materials, plastic region is very small. Plastic region is small. So as a result, what will happen means that material will break soon very easily. So an application of little force like wire. Next, what we can take here, ductile materials. Ductile materials is nothing but plastic region is large here. Plastic region is good. Next, elastomers means what means? Stress is not directly proportional to strain under elastic limits. Stress is not directly proportional to strain within elastic limit. Within elastic limit means upsilon not at all valid here. And one more point, what we need to tell means strain is more than stress for small forces. Strain is more than stress. If you apply small force also, elongation long will come in these materials. In which materials? In elastomers materials will get it. So how many types of materials we are having here? One is brittle material, another is ductile material, another is nothing but elastomers. So for these three, experimental study of this curves, stress versus strain curves we need to study here. So first curve will tell you about the what? Plastic region is small here. Second curve, plastic region, if you observe now here, this is little large compared to that. Plastic region is good. And third curve, elastomers means what means? Stress is not directly proportional to strain. So within elastic limit. So but strain is more compared to the stress means if you apply little force also, elongation is large in this, which we can discuss here. Behaves as a wire with spring constant K equal to Ya by L. So IA by L. So first what we need to do means here. So let me take one wire here. One thin wire. Whose Young's modulus is Y and whose length is L and whose area is A. Now what we are taking here? One more spring we are taking here. We are taking like this spring here. Whose spring constant is K we know here. So for wire you know that Young's modulus Y equal to what you know here? F by A into L by delta L you know here. So from here if you want to write force, no force, how can you write it? Remaining all will shift this side, no? So F equal to what we can write it here? A delta L will come to numerator. YA divided by L into delta L we can write it. Now let me take this in length L here. After application of load, what will happen? If you observe, no, I am giving some load here. If you giving some load, what will happen? Elongation will come. So how much elongation will come means delta X I am taking. So we know that force is directly proportional to extension delta X. If I remove proportional, we will get F equal to minus Kx. Or magnitude, if you want to write no, F equal to Kx, we can write it here. Now let me take this as equation number 1. Let me take this as equation number 2. If you observe 1 and 2, no, F equal to Ya by delta L, F equal to Kx we know. Kx in extension, how much we taken here? Delta X we taken, na? So let me take delta L, that would be better. So F equal to what we can write it here? K into delta L, I'm going to write here extension. Okay. So delta L, na? So if you compare these both, delta L, F. So K equal to what we got it here? Ya by L, which will get it here. K equal to Ya by L. One important relation to solve the all JEE CET numericals. JEE NEET CET numericals, we need to remember for sure this relation K equal to Ya by L, where K is nothing but spring constant, Y is nothing but Young's modulus, A is nothing but area of the wire, L is nothing but length of the wire, which we need to remember here. If and we know about the spring series combination, parallel combination, we already know. For example, if they given two springs like this, they given like this two springs, K1, K2 spring constant they're telling. So in which combination these two connected? Series combination. Series combination equivalent, what will get it? 1 by K equal to 1 by K1 plus 1 by K2. Or if we take LCM, what we can take here? K equivalent can be written as K1 into K2 divided by K1 plus K2, which we know here. For example, if they connect here parallel combination like this, if they connect springs, this is K1, this is K2. So what is the equivalent means? What we can write it? K equivalent can be written as K1 plus K2. Already we discussed here. For example, if they given one question like this here, they're giving one question. They given two spring constant like this. This is K, this is 3K. And this spring constant, another one is nothing but K they given here. Then they're asking, resultant one they're asking here. See, if you observe here, how these two connected here? This fellow connected parallel. If it is connected parallel combination, what will get it answer here? Just K1 plus K2. No? So if I add these two, no, these two will become like one spring whose spring constant is 4K, and this fellow will become like what here? K. So these two is in series combination. Now series combination, what will get it? K equivalent value. K equivalent is nothing but K1 into K2 divided by K1 plus K2. So K1 I'm taking like 4K, K2 I'm taking like K, divided by 4K plus K is 5K. 1K will get cancelled. As a result, answer will get it like 4K by 5, which we got it answer here. So this is how we can solve the combination of strings already, which we learned here. Let me choose another question here. They given like this. This is one spring. This is another spring. This is one spring. This is another spring they given. This is NDA, this is NDB. Calculate K equivalent between A and B if this is 3K, this is 3K, this is 1K, this is 2K. If you observe clearly how these two connected parallel combination. 3 plus 3 we can write like 6K. So that equivalent I'm writing like 6K I'm writing. How these two connected again? Parallel. Parallel means what we can write it 2K plus 1K is nothing but 3K. 3K we can write it. So this is A, this is B. These two are connected in series combination now. What is series combination formula we are having here? K equivalent is nothing but K1 K2 by K1 plus K2. So if you observe here now, so K equivalent can be written as K1 K2 divided by K1 plus K2. K1 value how much we are having here? 3K. K2 value how much we are having here? 6K divided by 3K plus 6K, 9K. K will get cancelled. 3 1 ja, 3 ja, 3 1 ja, 3 2 ja. Therefore, our K equivalent will get like how much we get it? 2K will get it for this question. This is how we can solve spring series combination, parallel combination, and the same topic which we have discussed in oscillations. Same topic. Now we are going to discuss about wires in series combination. We are going to discuss here. Wires in series combination. See what we are taking means we are taking two wires here. Like this, another wire we're choosing like this, we join together like this. This fellow Young's modulus is y1, area is a, length is l. This fellow Young's modulus is y2, area is a, length is l. So how we are going to analyze these things means we are going to analyze with the spring. So we are taking like, we are assuming like these two are nothing but two springs, whose springs constants are k1, k2. Why I am taking like this means we already discussed it. K equal to what we can write it here, ya by l, one relation we just derived. So by using that relation we're going to prove here. So you know that 1 by k, how these two connected series combination, 1 by k equivalent can be written as 1 by k1 plus 1 by k2, which we can write it here. So in the place of k equivalent, what we can write it here, y a equivalent, length equivalent, how these two connected series combination, no, length is how much, l plus l will be 2l. So I'm going to write 2l is will come denominator, no, that will go to numerator. 2l is equal to k1 value, y1, a1 is how much, na, a, l1 is how much, l. So what we can write it, y1 a divided by l, na, l will come to numerator, plus y2 a divided by l, which will get it here. Therefore what we can take common from here, 2l by ya can be written as l by a, if we take common, no, 1 by y1 plus 1 by y2, which we can write it here. So here l by a will get cancelled. As a result, what will get it here, 2 by y equivalent equal to 1 by y1 plus 1 by y2, which we got it here. So y equivalent, if you want to take LCM here, what will get it, y equivalent equal to what will get it, 2y1 y2 divided by y1 plus y2, which we got it here. This is a equivalent Young's modulus when two wires are connected in series combination. For how many wires we did here means two wires we did. I want to generalize this formula for n. So how can you generalize? In the place of 2, what I'm going to substitute, n. N by y equal to what we can write it, 1 by y1 plus 1 by y2 plus up to where we can write it, 1 by yn. For example, 3y is the given here. So what we need to write, 3 by y equal to 1 by y1 plus 1 by y2 plus 1 by y3. This is how we can generalize this formula. 2 wires, 3 wires, 4 wires, up to a number of wires, we can generalize this formula. This is an important formula which we have to remember when connecting series combination. No, n by y equal to 1 by y1 plus 1 by y2 plus up to here we'll get it 1 by yn, which will get it here. Now we are going to discuss Wires in parallel combination we're going to discuss here. Wires in parallel combination. Means we are taking two wires here. We are taking two wires, we are connected like these wires. This is one wire and this is another wire. So if you observe here now, for the second one, Young's modulus is nothing but y2 length is L, area is A. First one, Young's modulus is y1 length is L, area is A. If you observe clearly, what is increasing means this cross-sectional area will be increasing here. Length will be remain same. These both, how can we analyze means we can analyze like two springs connected in parallel combination. We can analyze. One spring is connected like this, another spring is connected like this. This is how these both connected, which we can analyze. This one we can take as K1, this one we can take as K2. Then what is K equivalent? You know that K equivalent in series combination, what we know here? Parallel combination, K equivalent can be written as K1 plus K2. And we know that K equal to what we know? K equal to YA by L we know. K equivalent can be written as Y equivalent. A equivalent is how much? These both areas getting added, no? A plus A will be 2A. 2A divided by length is L. K1 can be written as Y1A divided by L. Y1A divided by L. K2 can be written as Y2A divided by L. So, Y into 2A by L is equal to what we can take common? A by L we can take common. Y1 by Y1 plus Y2 remains here. So, A by L will get cancelled. 2Y equal to what we got it here? Y1 plus Y2. Therefore, Y equal to how much we can write here? Y1 plus Y2 by 2, which we got it. This is for how many wires connected parallel combination? Two wires connected in parallel combination. If three wires in connected in parallel combination, what we can write it? Y can be written as Y1 plus Y2 plus Y3 by 3 we can write it. For example, n wires connected in parallel combination, no? Y equivalent can be written as Y1 plus Y2 plus Y3 up to what we can extend? Yn over what will come here? N will come. This is the formula for what? N wires if connected in parallel combination. So these are the important formulas for only for competitive. They won't ask you for both. So we know that K equivalent is nothing but how much? K1 plus K2, which we know already. So if two wires connect in parallel combination, what we know here? Y equivalent equal to Y1 plus Y2 by 2. If they given three wires, will get like this. If they given n wires, now we need to remember this formula for sure. So this formula is very important for again JEE, your NEET and CET exams. For boards, they won't ask you. For CBSE also, for state board also, they won't ask you these questions for board exams. Fine. In this slide, we are going to discuss here, we are going to discuss about the potential energy stored in a wire. Potential energy stored in a wire. See, we studied already in work for energy about the spring we studied. If you take any spring here, no, if you elongate like this by giving mass, U is having spring constant K. So we'll get potential energy relation U equal to what will get it? Half Kx square. So the spring and this thing will get related where when spring constant K equal to what you know? Ya by L. So means energy I'm writing like U equal to half K into elongation I'm writing like just delta L, I'm choosing elongation. And K value I'm going to substitute here. U equal to half into Ya by L we are going to substitute here into delta L square. So what we are going to substitute here means, so U equal to what we can write it here? Half into Young's modulus into, so what I'm going to write here means Ya by L, right? A by L into L into delta L square is the right line, right? That, and I'm multiplying dividing with L. If you multiply and divide with L, no, area into length will become what? Volume. L into L will become L square. Therefore, U equal to what you can write it? Half into Y into area into length will become volume, and you can write like delta L by L whole square. Delta L by L whole square, because L into L will be L square here. Okay. So delta L by L whole square can be written as what, Nana? Strain square, we can write it, right? So U equal to half into Young's modulus can be written as what? Simply stress by strain. Strain into volume into delta L by L. Change in length by original length is nothing but strain square, we can write it. Strain square. One strain will get cancelled. Therefore, potential energy stored in a spring can be written as what? U equal to half into stress into strain into volume, which we got it. Sometimes they will ask you here potential energy stored in the wire. We got it now. Energy density they will ask you. Energy density they will ask you. So generally, what is meant by density? Mass density, mass by volume. Similar way, energy density is nothing but energy by volume. Energy relation, what we got it? U equal to half into stress into strain into volume, which we got it here. Energy density means what will get it here? Divide by volume. So U by volume equal to what will get it here? Half into stress into strain into volume divided by volume. Volume will get cancelled here. Therefore, energy, this symbol they given like small u here. Like this, they given energy by volume. UD equal to what we can write it? Half into stress into strain, which we can write it here. This is how we can prove this. This thing they will ask you for competitive as well as PU, they will ask you here. So this relation we already know, U equal to half kx square we know here. And you know that we just proved this relation also, k equal to ya by L, which we proved here. And what is energy stored in a wire means U equal to half into stress into strain into volume, which we can write it here. And energy density, if they ask you what we can write it, half into stress into strain. We just have to remove volume, that will get as what? Energy density, which will get it here. Let me have a look into one question here. The question says that what they're asking means here, they're asking like this. The stress versus strain graphs for wires of two materials A and B are as shown in the figure. If Young's modulus of A and Young's modulus of B are the Ya and Yb are the, they mention here clearly, Young's moduli. Young's moduli of the material. Then option A, they're asking Yb equal to 2Ya. Option B, they're asking Ya equal to Yb. Option C, they're asking Ya equal to, option C, Yb equal to 3Ya. Option D, they given Ya equal to 3Yb, they given. And along with the question, they given two graphs like this. This is the representation. Here what they mention here. Here they given stress. Here what they given means strain they given here. So here they given two slopes. This is slope B. This is slope A. Slope B value how much they given means 30 degrees they given here. Slope A value how much they given here? 60 degrees they given here. This is A. So they given stress strain curve. If you analyze here, no, it's very easy to solve this. So stress upon strain can be written as what? Young's modulus. Means slope under this fellow will give the Young's modulus. So we need to calculate slope. So Young's modulus of A, slope if you want to calculate, no, that's nothing but tan theta, right? Slope equal to tan theta. tan theta. So first, what is theta value for A? Tan 60 degrees. For B, what we know? YB equal to tan 30 degrees. So YA by YB can be written as what here? YA value is how much? Tan 60 is root 3. YB is how much will get it here? 1 by root 3. Therefore, YA by YB can be written as that root 3 into root 3 divided by 1 you will get it. So YA by YB will get as what will get it? 3 by 1. Therefore, YA equal to what will get it here? 3YB, which will get it here. So this is also one standard question which they can ask you for JEE, CET and all. So YA equal to 3YB means which of the following option is correct means option D is the correct answer for the given question. So let me take another example here. In this example, what they given means they given one wire here. They elongate it with mass m like this, whose Young's modulus y, length is L, area is A. So what they want to relate means they want to relate the Young's modulus here. So what we know Young's modulus relation, just we derived that in last session. Y equal to what we know that F by A into delta L by L, right? L, FL by A into delta L, we got it here. So in the options they given like clearly Y equal to FL by A into L dash minus L. So that's nothing but delta L. So this is a clear option which they asked in NEET 18 around direct 4 marks question which they asked. So this is directly a formula based question which we can remember here. So let me discuss one more question here. In this question, what they're asking is they're asking like this. Question says the Young's modulus of a wire the Young's modulus of a wire of the Young's modulus of a wire of length L and radius R is Y newtons per meter square. Whose length is L, radius is R, is nothing but Y newtons per meter square. If length and radius are reduced to L by 2 and R by 2, then its Young's modulus will be they're asking. Options they given like option A Y by 2, option B Y, option C 2Y, option D 4Y they given here. So if you observe clearly, they're changing what dimensions they're changing here. So length is decreasing to L by 2 and radius is decreasing to R by 2 means area is decreasing here. But if you observe here, no, on whom we need to comment, on Young's modulus we need to comment here. So basically, you know that why Young's modulus is nothing but material property. Material property. It is different for different material. For example, for copper it is different, for ferrous it is different, okay, for nickel it is different. That depends on the material, it does not depend on the dimensions of the material. So that's why Young's modulus remains constant if dimensions is changed here. So next question they're asking like this. What they're asking means this is very standard question for every competitive exam. Let me choose the question. Yes. Question says like this. If the ratio of lengths, radii and Young's moduli of steel and brass wires In the figure, are A, B, and C, they given are respectively. Then the ratio of, then corresponding ratio of, increase in their lengths would be option A, the given like 2a square by c, 2a square c by b. Option B, the given 3a by 2b square c. Option C, the given 2ac by b square. Option D, the given 3c by 2ab square, the given. In the question, along with the question, they given one diagram here. How does the given diagram means? They given here like this. This is mass m is connected. Here mass block of 2m is connected. See, to solve this, little knowledge of Newton's laws of motion is required here. So, little typical question in every standard book you can get this question, a similar question. Okay. So we know that they're asking what corresponding increase in their lengths will be, means delta L they're asking here. We know that Young's modulus is equal to what we know, y equal to FL by A into delta L. They would like to know about the delta L. Delta L equal to what we can write it here, FL by A into y will get it here. Okay. Now we have to know about the ratios what they given in the question. If you read the question, no, if the ratio of the lengths, radii and Young's modulus is nothing but they mention A, B, C. Just collect the data first. What they given here? LS by LB equal to A they given. RS by RB equal to B they given. YS by YB equal to what they given here? C they given here. So then they want to know about the ratio of delta LS to the delta. What they're asking, that's what, right? Delta LS to the delta. Another is nothing but brass wire. No? This is nothing but steel. And this is nothing but brass wire. So what we need to know here, delta LS divided by delta, what we need to calculate here? Delta LS to the delta brass, right? Another one, delta brass is equal to FS by F brass into LS by L brass. Area is reciprocal, no? That's why AB by AS and Young's modulus is also reciprocal here. It is in denominator. What we can write it here? YB by YS, which we can write it here. So delta LS by delta LB equal to, we need to substitute the values. What we have to know here clearly means, what is the net weight on this fellow means actually. So how much is acting means on this fellow downward 2 mg is acting here. So what we can tell means F brass equal to what we can write it here, 2 mg we can write it. But if you observe on this fellow, no, we have to consider these two like one block here. So total mass will become how much? 3m. So for 3m downward, how much is acting? 3 mg is acting for steel, because this fellow is pulling by 2 mg and this fellow is pulling by 2 mg. So steel value, if you want to calculate now here, F steel equal to what will get it? 3 mg, which we got it here. This is we have to realize here. Now Fs by F brass. Fs by F brass is how much? Fs is how much? 3 mg divided by F brass is nothing but how much will know? 2 mg. And LS by LB. LS by LB value how much we are having? A we are having. A. And AB by AS. AB by AS we don't know. First we need to convert in terms of radius. So how can we write it? AB is nothing but pi RB square divided by pi RS square. Pi will get cancelled. RB by RS square we can substitute. And YB by YS value we know. YS by YB we know. YB by YS means what we need to do? We need to reciprocate value. So this mg also will get cancelled. Delta LS to the delta LB equal to what we can write it here? 3 by 2 A RB by RS whole square. RS by RB value what we are having? Y. If you reciprocate that, what will happen? 1 by B will having. So 1 by B But what is there here? Square is there for both of them, no? 4 square divided by 1 by c. So delta ls divided by delta lb will get like 3a divided by 2b square c, which we got it here. This is the answer which we got it here. Hopefully, which option is matching? 3a by 2bc, 2b square c. Yes, option B is correct here. So this is also, we know that generally Young's modulus we know here. In the question they given data, we need to collect carefully. Then we need to check here. They given about the radius, no, area is nothing but pi r square. We just did that. And this is nothing but reciprocals is there. You just have to take carefully, then we need to solve. This is how we can solve this answer here. Important question, have to practice well. Fine, dear students, this is for today's class. For better performance, please do revise once again. Thank you.